In this video, we will continue to work on graphing quadratic equations. Now, in terms of what we have here, y equals ax squared plus bx plus c is the standard form of a quadratic function. Ax squared is what we call the quadratic term because it has the x squared. Bx is what we call the linear term because it's just an x. And c is the constant term, or just a number. Now, in these examples, we're just going to practice identifying the value of a, b, and c. A is whatever the first number is. So for the first example, this is a, that's b, and that's c. So we could say a equals 2, b equals negative 12, and c equals 21. For the next one, since there's nothing in front of the x squared, that means it's really 1. So that's a, b, and c. So a equals 1, b equals 6, and c equals 8. For the next one, it's really a negative 1 in front of the x squared. So that would be a, b, and c. So a equals negative 1, b equals 4, and c equals negative 1. For the last one, since this is x squared, we could really add in that it would be plus 0x plus 0, because we're just missing those terms. Now in front of the x squared is really a 1. So that would be our a, b, and c. So a equals 1, b equals 0, and c equals 0. Now the axis of symmetry is the line that vertically divides the parabola into two mirror images, like we have below. The equation for the axis of symmetry is always x equals with a number. And since the axis of symmetry goes through the vertex, it is x equals the x-coordinate of the vertex. So the axis of symmetry in this example is x equals 3. Now the y-intercept is the point in which the line crosses the y-axis. So in this case, the y-intercept is 0, 2, because it intersects right here. Now in order to calculate the axis of symmetry, you need to calculate the x-coordinate of the vertex using the equation x equals negative b over 2a. And then you're going to rewrite it as x equals. To calculate the y-intercept, you're just going to write the order pair 0, c. In our first example, we have the equation y equals 2x squared minus 12x plus 21. First, let's identify the values of a, b, and c. So the first number is a, b, and c. So we could say that a equals 2, b equals negative 12, and c equals 21. Now, if we want to calculate the axis of symmetry, it's always x equals negative b over 2a. So if I substitute, it would be x equals negative times negative 12 over 2 times 2. Now if I simplify, negative times negative 12 gives us positive 12. 2 times 2 is 4. So we divide 12 by 4, so you'll get x equals 3. Now your y-intercept is always 0, c. So in this case, since the c value is 21, the y-intercept is 0, 21. And that's your final answer. For our next example, again, we want to identify the value of a, b, and c. So whatever is in front of x squared is a, in front of x is b, and the last number is c. So a equals negative 1, b equals 4, and c equals negative 1. Now the axis of symmetry, we said before, is x equals negative b over 2a. So if we substitute, we have x equals negative times 4 over 2 times negative 1. If I multiply, you'll get negative 4 over negative 2. And that simplifies to give us x equals 2. And your y-intercept is always 0, comma, c. So in this case, it's 0, comma, and the c value is negative 1. For our last example, we have the equation y equals x squared, which we can rewrite as y equals x squared plus 0x plus 0. Now, if I identify the values of a, b, and c, this means there's really a 1 in front of the x squared. So that'd be our value of a, our value of b, and our value of c. So we could say a equals 1, b equals 0, and c equals 0. Now the axis of symmetry is x equals negative b over 2a. So we have x equals negative times 0 over 2 times 1. If I multiply, you'll get 0 over 2. So it becomes x equals 0. For the y-intercept, it's 0, comma, c. So in this case, since the c value is 0, it becomes 0, comma, 0.